Hello and welcome to Mental Math for Kids. In this video, we are going to be talking about division. Are you ready? Let's go. I am going to be teaching you some quick tips to determine if a number is divisible by 1 through 10. I'm going to be sharing with you the divisibility rules. Divisibility rules can be very helpful. They allow a student to quickly check whether a number is divisible by another number without actually solving out the equation. If a number is completely divisible by another number, then the quotient or the answer will be a whole number and there will not be a remainder. Multiples of a number will always be divisible by that same number. For example, if I have the number 4, well, what are the multiples of 4? 4, 8, 12, 16, 20, 24, 28, 32, and we could skip counting, right? Well, all of these numbers are evenly divisible by 4 because they are multiples of 4. We know 4 divided by 4 equals 1. 8 divided by 4 equals 2. 12 divided by 4 equals 3. There's no remainder in any of these answers because these numbers are all evenly divisible by the number 4. And that's true for any number. All of their multiples will be evenly divisible by that number. The divisibility rule of 1. The divisibility rule of 1 says that every number is divisible by 1. The answer will always be the same number you are dividing by 1. For example, if I'm dividing 1 by 1, my answer is 1. What if I'm dividing 2 by 1? Well, 2 divided by 1 equals 2, the same number. 10 divided by 1, well, that's 10, the same number. 20 divided by 1 is 20. And this would be true for any number. When you're dividing by 1, the answer is that same number. The divisibility rule of 2. The divisibility rule of 2 says that if the number is an even number, 2, 4, 6, or 8, or the number ends in an even number, including 0, then it is evenly divisible by 2. Let's look at some of these equations. The first one says 8 divided by 2. Now, 8 is an even number. So we would know right from the start, yes, this equation is evenly divisible by 2. And we get that nice whole number of 4 there without any remainder. What about the number 26? Is it evenly divisible by 2? Well, look at the last digit in the number in the ones place. It's a 6. And 6 is an even number. So this number, 26, will be evenly divisible by 2. And if we solve it out, we get 13. How about the number 107? Well, let's look at the digit in the ones place. It's a 7. Is 7 an even number? No, it is not. So 107 will not be evenly divisible by 2. This one we would get a remainder. How about 428? Well, what number's in the ones place? An 8. Is it even? Yes, 8 is an even number, so 428 will be evenly divisible by 2. The divisibility rule of 3. The divisibility rule of 3 tells us that we can test to see if a number is divisible by 3 by adding the digits in the number together. If the sum of those numbers is divisible by 3, then that number will also be divisible by 3. And if the number is a multiple of 3, then it will be evenly divisible by 3. Let's look at these equations. The first one is 9 divided by 3. Well, we know 9 is a multiple of 3, right? 3, 6, 9. And so we know that this number 9 will be evenly divisible by 3. And we get that answer of 3. How about 33 divided by 3? Well, instead of solving this out, let's just look at it first. And we're going to take the digits in the number 33, and we're going to add them together. So we're going to say 3 plus 3. Well, that's a 6. Is 6 a multiple of 3? 3, 6, 9, 12. Yes, 6 is a multiple of 3. So 33 will be evenly divisible by 3. And here's our answer of 11. No remainder. How about the number 48? Well, to test this one, we have to add the digits in the number 48 together. 4 plus 8 equals 12. Is 12 a multiple of the number 3? 3, 6, 9, 12. Yes, it is. So 48 will be evenly divisible by 3. And we get the answer of 16. Let's check 53. 53 divided by 3. We're going to add the 5 and the 3 together, and that gives us 8. Is 8 a multiple of 3? 3, 6, 9. Nope, 8 is not a multiple of 3. Therefore, 53 is not evenly divisible by 3. The divisibility rule of 4. The divisibility rule of 4 tells us that if the last two digits of a number are 0, 0, or if the last two digits of the number are evenly divisible by 4, then that number is evenly divisible by 4. Let's look at the first one, 12 divided by 4. Now we know 12 is a multiple of 4, so that's going to be evenly divisible by 4, and our answer is a 3. Let's look at this one, 100 divided by 4. Oh, this number 100 has two zeros in the tens and the ones place. Therefore, we know, according to our divisibility rule, this number will be evenly divisible by 4. So any number that ends in 0, 0, 100, 200, 300, 400, 1,000, any of these numbers will be evenly divisible by 4. And if we solve that out, we get 25. Let's check 247. Okay, it's not a 0, 0. So the next way to check this would be the last two digits of the number are 4 and 7, or 47. Is 47 a multiple of 4? Well, you might have to solve this one out because it's a larger number. And if you did that, you would find that no, 47 is not evenly divisible by 4. Therefore, 247 also is not evenly divisible by 4. Let's look at this last number, 3016. 3016 does not end in 0, 0, but let's focus on these last two digits. There's a 1 and a 6, which is the number 16. Think, is 16 a multiple of 4? 4, 8, 12, 16. Yes, it is. Since 16 is a multiple of 4, then 3016 will be evenly divisible by 4, and we get the answer of 754 for that one. The divisibility rule of 5. The divisibility rule of 5 tells us that if the number ends with a 0 or a 5, then that number is evenly divisible by 5. Okay, let's look at some of these equations. We have 15 divided by 5. Is 15 evenly divisible by 5? Yes, it is. 15 is a multiple of 5, 5, 10, 15. So we know that it will be evenly divisible by 5. And it ends in a 5. Let's look at the number 100. What's the last digit? It's a 0. So we know that this number 100 will be evenly divisible by 5 because it ends in a 0. And 100 divided by 5 equals 20. Let's look at the next equation, 504 divided by 5. Look at the number in the ones place. It's a 4. 4 is not a 0 or a 5. Therefore, this whole number, 504, will not be evenly divisible by 5. You would have a remainder with that one. How about the number 2005? Well, it ends in a 5, so it is evenly divisible by 5. And the answer would be 401. No remainder with that equation. The divisibility rule of 6. The divisibility rule of 6 tells us that if a number is divisible by 2 and 3, then it will also be evenly divisible by 6. So we have to know the divisibility rules for 2 and 3 to find if a number is divisible by 6. So if you remember, for 2, if the last digit in the number is an even number, including 0, and for 3, the digits add to a multiple of 3, then that whole number will be evenly divisible by 6. Let's look at a few examples. The number 54. Well, 54 ends in a 4. 4 is an even number, so this works for our 2's. Let's check our divisibility rule of 3. Let's add the 5 and the 4 together. 5 plus 4 equals 9. 9 is a multiple of 3. 3, 6, 9. So now we know 54 is divisible by 6. And you probably have this one memorized. 54 divided by 6 equals 9. Let's look at the next equation, 150 divided by 6. Look at the number in the ones place. There's a 0 here. Since there's a 0, we know that this number is evenly divisible by 2. Now let's check, is it evenly divisible by 3? Well, let's add these numbers together. There's a 1, a 5, and a 0. If we add 1 plus 5 plus 0, we get 6. 6 is a multiple of 3. 3, 6, right? So it fits. It fits the rule of 2 and 3, and therefore 150 is divisible by the number 6, and we get the answer of 25. Let's look at this one, 304. Ooh, the number in the ones place is a 4, which is an even number. Okay, so it's divisible by 2. Now let's check, is it divisible by 3 evenly? Well, we have to add these digits together. 3 plus 0 plus 4 gives us 7. Is 7 a multiple of 3? 3, 6, 9. Nope, it is not. So now we know the whole number 304 is not evenly divisible by 6. This one we would get a remainder. Let's look at the last equation, 2013. Look at the number in the ones place. There's a 3 here. Now we know right from the start, 3 is an odd number, therefore it will not be evenly divisible by 6. If we were to check for the divisibility rule of 3, it does pass that rule. 2 plus 0 plus 1 plus 3 equals 6. And 6 is a multiple of 3, but because it doesn't pass the divisibility rule of 2, then we know that this whole number, 2013, is not evenly divisible by 6. The divisibility rule of 7. The divisibility rule of 7 says that to check if a number is evenly divisible by 7, take the last digit in the number and double it. Then subtract that answer from the remaining number. If the answer is a multiple of 7, then the whole number is evenly divisible by 7. You can repeat this process until you get to a small enough number that you recognize as a multiple of 7. This one's a little bit more complicated and it works easier with smaller numbers, but let me show you what I mean. We have the equation 903 divided by 7 to check if this number 903 is evenly divisible by 7. Our first step is to look at the number in the ones place, and we're going to double this number. So there's a 3 here, so we're going to add 3 plus 3. That gives us a 6. Now we're going to take the two numbers that are left, which are 9 and 0, or the number 90, and subtract this 6. 90 minus 6 equals 84. Now, is 84 a multiple of 7? Yes, it is. If you know your multiplication times tables, you know that 7 times 12 equals 84. And so we would know this number, 903, is evenly divisible by 7 by using this rule to help us check. And the answer is 129. There's no remainder. Let's try another one. This equation is 1,341 divided by 7. We want to know, is 1,341 evenly divisible by 7? Well, you're going to look at the number in the ones place first and double it. There's a 1 here. So we're going to say 1 plus 1, well, that equals 2. Okay, now we're going to take the numbers that were left, 1, 3, and 4, and we're going to bring those down. So we have 134. We're going to subtract that number, the answer, from when we doubled the last digit, which is a 2. So now we have 134 minus 2. That gives us 132. Now, I don't know if 132 is a multiple of 7. So we can simplify this again by doing the same process. Let's take the number 132. Look at the number in the ones place. There's a 2. We're going to double that 2. 2 plus 2 is 4. What number is left? A 1 and a 3, which would be 13. So we're going to take 13 minus 4, and we get the number 9. This is much easier to work with and see now. Is 9 a multiple of 7? 7, 14? Nope, it is not. So now we know this whole number, 1,341, is not evenly divisible by 7. This one would give us a remainder. The divisibility rule of 8. The divisibility rule of 8 tells us that if the last 3 digits of a number are divisible by 8, then the whole number will be evenly divisible by 8. Now this one is a little bit harder too because we're working with larger numbers, but it still can be helpful. Let me show you an example. If I have the equation 1024, I need to look at the last 3 digits. There's a 0, a 2, and a 4 here. Well, I know 024 is just the number 24. Is 24 evenly divisible by 8? Yes, it is, right? 8, 16, 24, it's a multiple of 8. And so if these 3 numbers are evenly divisible by 8, then this whole number is also evenly divisible by 8. 1024 divided by 8 equals 128. There's no remainder. Let's look at this one. 20,418. For this rule, it says we have to look at the last three numbers, which are 418. Is 418 evenly divisible by 8? Well, I don't know. I might have to work this one out. And if I solve this one out, I got the answer of 52 remainder 2. This tells us that 418 is not evenly divisible by 8. So now we know this whole number, 20,418, is not evenly divisible by 8. We would get a remainder. The divisibility rule of 9. The divisibility rule of 9 tells us that to test if a number is divisible by 9, add the digits in the number together. If their sum is divisible by 9, then that number will also be evenly divisible by 9. This is kind of like our rule for 3s, only instead of being a multiple of 3, we have to determine if it's a multiple of 9. For example, we have the number 90. Is 90 evenly divisible by 9? Well, yes, we already know this, don't we? We know our math facts, so we know 90 divided by 9 equals 10. But if we were to check it, we just take the digits in the number 90 and add them together. 9 plus 0 equals 9. And 9 is a multiple of 9, right? 9, 18, 27. And so this equation is evenly divisible by 9. Let's try the next one, 747. Is 747 evenly divisible by 9? Well, let's add these digits together and find out. 7 plus 4 plus 7 gives us 18. Well, 18 is a multiple of 9. 9, 18. So this whole number, 747, will be evenly divisible by 9. And if we work it out, we get the answer of 83. Let's try this one, 1,223 divided by 9. Is this number evenly divisible by 9? Well, let's add the digits together. 1 plus 2 plus 2 plus 3. That gives us 8. Is 8 a multiple of 9? No, it is not. And so now we know that this number, 1,223, is not evenly divisible by 9. When we solve it out, we'll get 135 remainder 8. So this one would have a remainder. Okay, the last one, the divisibility rule of 10. If the number ends with a 0, then that number is evenly divisible by 10. Now you are probably very familiar with this one. Let's look at some examples. 20 divided by 10, 20 ends in a 0, therefore we know it is evenly divisible by 10, and the answer is 2. How about 771? Well, the last number is a 1, it's not a 0, so this equation, or this number, 771, is not evenly divisible by 10. We would have a remainder. How about the number 9,340? Well, what number is in the ones place? A 0, and according to our rule, if there's a 0 in the ones place, then this number will be evenly divisible by 10. And it is 9,340 divided by 10 equals 934. And these are pretty easy because all you have to do is take that 0 off the number you're working with, and that's your answer. Well, that is it for today's video. Thank you so much for joining me today. I hope that you enjoyed learning about the divisibility rules for the numbers 1 through 10.